Hi guys, and welcome to a new video. So as you can see, the problem today is to solve the following equation. The integer part of 2x plus 1 divided by 3 plus the integer part of 4x plus 5 divided by 6 is equal to 3x minus 1 divided by 2. Well, now that is a complicated equation. Now we're no longer dealing with just the integer part of x. Now we have the integer part of one thing plus the integer part of another thing is equal to, this expression. So how the heck do we start here? So what can we do here? So, well, to begin with, if I can make some comments first. So if we look at the left-hand side of this equation, so we can notice that it is the sum of two integers, and therefore it is an integer. And since we have an equation here, so the right-hand side has to be an integer as well. So this is the first conclusion. And now the second conclusion, since this is an integer, then 3x minus 1 is an even integer, because since this is an integer, then the numerator has to be divisible by the denominator, and that's why 3x minus 1 is even, which leads to the fact that 3x has to be an odd integer. So the second comment is that 3x is an odd integer. And now the third comment, I want to rewrite 4x plus 5 divided by 6. And I do it in this way. So it's equal to 4x plus 2 plus 3 divided by 6. Then I divide this ratio into two ratios. The first one is 4x plus 2 divided by 6. And the second one is 3 divided by 6, which leads to 2x plus 1 divided by 3 plus a half. Well, what can we see here? So now we see that this term here inside the square brackets reappears here. And this is a good thing. So by noticing that, I want to rewrite the whole equation, and it will have the following form. And to make this easier, so I want to make a change of variable here, and I want to set t equal to 2x plus 1 divided by 3. So I want to make now a change of variable. So I make the following change of variable. T equal to 2x plus 1 divided by 3, and then I substitute in the equation, so I get the integer part of t plus the integer part of t plus a half is equal to, and the right-hand side written in t would be 90 minus 5 divided by 4, which is obviously an integer as well. Now we have a new equation here. It's still the same equation, but the difference here is that the left-hand side, I can show that the left-hand side is equal to the integer part of 2t, and this is done in a video that I made half an hour ago. So I proved this equality. So now by substituting this by the integer part of 2t, so I have this equation, which using the definition of the integer part function would give me this double inequality. And by adding now 1 to this, I will get this new equality. And to make it easier, I multiply by 4, which is a positive number, so those do not change. So I get this new equality, this new double inequality. And now the left-hand side inequality would give me this one. And the right-hand side inequality would give me that one. And those together means that t belongs to this interval. So I managed now to find to which interval t belongs. And I want to go back to this equation. So now, if t belongs to this interval, then 2t would belong to the interval 2, 10. Okay? And I want the integer part of 2t, and the integer part of 2t is one of the following: 2, 3, 4, up to 10. And this is because 2t belongs to this interval. And the integers in that interval are 3 to 10, except 2, but 2 has to be taken into considerations because of the integer part function. So I have shown now that the possible values of the integer part of 2t are those values. And now I want to study each one of them. So, and remember this equality. So remember this. So now if the integer part of 2t is 2, then since this one and this one are equal, then 9t minus 5 divided by 4 equal to 2. And by this operation, so we have got rid of the square brackets. And solving this equation, so t is 13 by 9, and going back to t equal to 2x plus 1 divided by 3, and solving this new equation in x, we get x equal 5/3. And then I will take each case then and solve for x. So finally, those would be the solutions to our equation from the beginning. Well, thanks guys for watching, and see you in the next video.